In this video, I'm going to demonstrate the attack against Windows structured exception handling. On Windows, when we run a program, if there are exceptions, actually the exception handlers are stored on the program's stack. Therefore, if the program has a buffer overflow problem, then we may overflow the buffer and overwrite the exception handlers so that we can run our own code. So here is what I'm going to do. So you can see this is our Windows VM, and I'm going to actually perform some debugging. So within this Immunity Debugger session, I'm going to start VChat. This is our wearable chat server, and then we start it and then make sure it is running. Okay, and then in Caddy, I have a fuzz script. So this fuzz script is going to fuzz the GMON command of our wearable chat server. So you can see here is our Python script. So first we import bootfuzz, we import sys module, and here we don't really need this callback function. So here is our main function. We specify the host port number, then we specify, we use 3 loggers to save the fuzzing session. Then we create the session. You can see here, right? We actually target, this IP address and this port, and we also save everything the fuzzer does into these 3 loggers. So this is the fuzzing template, and then we call this fuzzing request as a GMON, right? And this is the start of the string. We are going to send it to the valuable chat server. It starts with GMON. We don't want to fuzz this command. Then we have a space as delimiter. And here is the message we are going to fuzz. We call this A, but bootfuzz is going to change A and using random strings. And then finally here we have this return new line to end the message. Okay, so then we are going to fuzz, right, this target running at IP 10.0.2.15 and port number 9999. Okay, so here is the funnel script. So as we know, right, I want to actually stop, the fuzzing session when I see something weird happening within this Windows valuable chat server, right? And so let's have a look. Do I have how many sessions we have? Okay. Okay, so we are already have the source code here. So I'm going to do this. Okay, and I'm going to do Python and bootfuzz. Right, so this is what we're going to do to fuzz it. So whenever I see here something changes or crashes, then I stop the fuzzing. So let's wait. Okay, and let's have a look. Where did I stop? I stopped here, and good. So if we actually look at the emu debugger session, they can see. So basically, looks like this is our, you know, string that crashes this valuable chat server session. And or however, if we look at the EIP here, right, and so it doesn't look like this string. So it basically this crash occurs before the victim function returns. So actually, some exception occurs, and the exception handler was activated. So if we look at SEH here, right, you can see here it says corrupt entry. Okay, so basically the long malicious message causes the SEH handler chain being crashed. Okay, and so to find out the size of the malicious message to crash the SEH handler, so let's do this. Okay, so we restart everything, right? And then we come to here. So what we are going to do now is, so let's look at the length of this malicious message. So it's 10007. Great. And so what I'm going to do here is, so I'm going to actually create a long message like this. So we use a pattern create to create a unique string. So the goal here is to pinpoint how many, characters we need to overwrite the SEH handler. Okay, and you can see this is the string we created, and so this is actually within this. So the same thing here. Okay, and so now let's run this, see what happens. Okay, but again, we're going to make sure. So this is running, and then we are going to use this Python script to send this long string and see what happens. Okay, so I'm going to do Python. This should be export one. Okay, and then here, and so now I'm going to actually push Shift F7. So you can see here, right? We come back to, the program. Okay, the reason I pushed Shift F7 because when an exception occurs, a multi-debugger is given the first chance to process the exception. Then when I push Shift F7, then this program will get the chance to process the exception. So you can see here, so the EIP we have here is like this, right? And this is actually from our malicious string. If we copied it, copy selection, good. So that's a 3070. Okay, so let me have a look here. And so basically, that's a 3070, right? So what I try to do is I want to find out the offset of that you know, you can call this character or string or the address, whatever, but this part of the string we send, right? So we want to find the offset and within this long string here. And so we can do this. I'm finding my old command. So it's here, 3070, right? Good. So you can see we needed this many. Okay. So this is how we actually, find out the length of string we needed to use to overwrite, SEH. So if we have a look at the SEH chain, you can see that's what we did. Okay. And good. So here, let me show you the final attack. So this is our final attack script. Exploit 6 here. So let's have a look at what's going on here. So you can see first we have socket struct sys modules imported into our Python script. And here you can provide the target IP, right, to perform this attack. Right here, so you can see here we specify the host IP, the port number. This is our shell. This is a band shell, right? So eventually the band shell will run, and then we can actually use a nc command to collect to this band shell. So this is our attack string. So you can see here we have a GMON here, right? Then we have the shell code. Then we have a lot of padding here. So you can see here, this one is very interesting, and this one is also very interesting. Then here, actually, this is an address we are going to use to override the SEH handler. Okay, and so then you can see here we have a 2C here. Then we have this long jump. This is a jump, right? Jump to actually the start of the shell. And so this is fixed, right? So that we can know this easily. Okay, so I'm going to actually perform debug to show you how this works. Okay, good. And so let me run this attack, right? So what I'm going to do here is, you can see here. So in this code, I told you I use this address to overwrite the SEH handler. So I'm going to set a breakpoint at this. Let me have a look. Is that right or not right? Okay, I need to copy this right. And I copy this to here. Okay, something's wrong here, and I need to make sure I copy this right. So I cannot copy this out. Copy. Okay, something is wrong here. Okay, so this is a 6250271B. Okay, 6250271B is good. Okay, then we copy to here. Okay, and so good. So you can see this is actually a gadget, and we can use Mona to find this gadget. And in the tutorial, we have the command of Mona finding this gadget. Okay, And so now let's set a breakpoint here. So then we run everything here. Good. Let me see here. Yes, the valuable chat service running. Now let's perform the attack. See what happens. So I'm going to perform this attack. So I'm going to run attack script number 6. Okay, good. So basically, you can see here an exception occurs, and a muted debugger picks up the exception, right? So now we push Shift F7 here to let the program to handle it. So as I mentioned, you know, we use this address to override the SEH handler, as we can see from here, right? And so I need to go back. So when the exception occurs, you can see indeed we come to this location. And so at this location, we have 2 pop, 1 RETN. And if we look at the stack here, okay, so basically, you know, this address is very interesting. This address actually is within our buffer. It's a D0FFCC. D0 FFCC, right? And so that's what we're really doing here. Okay, so let me go back to the ESP. Okay, so you can see here, what this gadget does is do 2 pops. So when we do 1 pop, this will go. When we do second pop, this will go. And finally, so, you know, the ESP will point to this location. Okay, now when RETN runs, basically it will return to run this run the instruction at this address. We run. So we are going to go to this location to run the instruction over there. Okay, so we actually come to here, and right, we come to actually to run this instruction. So so the stack actually is here, right? This is the top of stack. That's the ESP, okay? And but we are going to run, you know, this instruction at this location, okay? So you can see here. So at this location, we actually save this, you know, short jump. It jumped to where? FFD6, FFD, this is FFCC, right? So we go to FFD6 somewhere here. Okay, so let's do the jump. So, right, so it's jumped to this location. So at this location, okay, and so we have another jump. This will jump to actually the beginning of the shell code. Okay, so before we run the shell code, So this is what the stack looks like. So we really don't know where ESP is, right? But ESP is here, and what our buffer actually is here. Okay, and so at 000 F1DD, F1DD, that's what we are doing here, running the code, right? F1DD, somewhere here, right? It's stored our shell code. So then the shell code will run. Okay, and so that's what happens. That's how we actually construct the malicious string. So now I'm going to actually run the attack to show you actually it works. Okay, so we come to here. So I'm going to perform the attack. Then I'm going to actually use NC to collect to the bind shell. So you can see it works. So let's have a review of how we constructed the malicious string. Okay, so this is what it looks like, right? First, we have GMON, right? This is the command we are going to attack. Then we have the shell code. Then we have the padding a sequence of A's. Now here we have, the jump short command. Then we have 290 as padding. Then this address is the address of a gadget, and this gadget to override the SEH handler. And here we have some padding, and here we have actually our long jump. So here is what will happen when we send this string to the target. So when this string is sent to the target, basically buffer overflow will occur, and this address will override the SEH handler. So now when the target vulnerable function has an exception, right? Basically, this gadget will work, and it do two pop, then do RETN as we recall, right? And so basically, we know when RETN returns, it will pop an address stored on the stack to EIP. Luckily, that address points back to our buffer right here. Okay, and so then here you can see basically we put a jump short instruction here. So this will jump to the location to here, and this is a jump long command. It will jump actually to our shell code. Okay, so you may wonder, okay, why you don't jump from here to the shell code? Because you can see for this jump instruction, it has 5 bytes. So if we put 5 bytes here, 1, 2, 3, 4, 5, then basically we are going to overwrite, this address. So we cannot actually do that. That's why we put a short jump. We jump first to the top, then over there we put another jump instruction. And here we have enough space, so we can just jump back to our shell code. Okay, so this is the whole story of the attack against the SEH.